Okay, good morning all of you. Today I am going to explain cells, electrochemical cells. Electrochemical cells. Okay, Unacademy offers YouTube live classes. YouTube live classes. YouTube live classes. And myself again, educator live classes. Okay, top educator in Unacademy. Today I am going to explain electrochemical cells, construction and working of electrochemical cells, construction and working of electrochemical cells. Okay, so what are electrochemical cells? What are electrochemical cells? A device which is a device which is used to convert chemical energy. A device which is used to convert chemical energy of a spontaneous redox reaction. Chemical energy of a spontaneous redox reaction into electrical energy. Electrical energy is called electrochemical cell or Daniel cell or galvanic cell. Electrochemical cell or galvanic cell or voltaic cell. Best example for electrochemical cell is Daniel cell made up of zinc and copper electrodes. Okay, what is electrochemical cell? Electrochemical cell consists of two half cells. Each half cell is called a single electrode. Okay, so electrochemical cell consists of two single electrodes. So this is one single electrode and this is another single electrode. Okay, so each half cell means single electrode, are constructed by single electrodes are constructed by ఎట్లా construct చేస్తాం or constructed by single electrodes are constructed by a metal and its ions solution or by using a non-metal or by using a non-metal and its ions solution. The construction of a single electrode. For example, zinc metal, when placed in contact with its ions solution, we will get corresponding a single electrode. If a copper metal is placed in contact with its ions solution, we will get corresponding electrode. Each half cell is constructed by a metal and its ions solution or a non-metal and its ions solution. Okay, and the two half cells are externally connected by a copper wire through voltmeter or ammeter. The two half cells are externally connected by voltmeter or ammeter with the help of copper wire. What is the use of voltmeter or ammeter? To determine the strength of current produced in this cell from a spontaneous redox reaction. We use voltmeter or ammeter. And based on direction of the depletion of voltmeter needle. So voltmeter lo unde needle direction basis we can determine direction of the current produced in this cell. So voltmeter or ammeter వల్ల రెండు uses ఉన్నాయి. One is used to determine strength of the current. Second one is used to determine direction of the current. And the two half cells are internally connected by a salt bridge. The construction of electrochemical cell or galvanic cell or voltaic cell. Best example, Daniel cell, made up of copper and zinc electrodes. So electrochemical cell consists of two half cells or two single electrodes because each half cell is called a single electrode. And single electrodes are constructed by using a metal and its ion solution or a non-metal and its ions solution. The two electrodes are externally connected by voltmeter or ammeter with the help of a copper wire. And fourth point, the two electrodes are internally connected by a salt bridge. Okay, this is about the construction of electrochemical cell. Student, zinc rod suspended in zinc sulfate solution. Copper rod suspended in copper sulfate solution. And the two are externally connected by a salt bridge. The two are externally connected by a salt bridge. This is a salt bridge. Okay, now internally connected by salt bridge. Okay, right. Working of galvanic cell. How it produces electrical energy from chemical energy. So zinc rod suspended in zinc sulfate solution acts as left hand side half cell. Copper rod suspended in copper ions solution acts as right hand side half cell. Left hand side half cell, right hand side half cell. This is the left hand side half cell and this is right hand side half cell. Left hand side half cell and right hand side half cell. Okay, the left hand side half cell and right hand side half cell. This left hand side half cell consists of zinc rod suspended in zinc sulfate solution. Right hand side solution consists of copper rod suspended in copper sulfate solution. When the two are externally connected by a copper wire through salt bridge or volt bridge due to high electropositive character, zinc undergoes oxidation. Due to its high electropositive nature, zinc undergoes oxidation. Okay, so at zinc rod, zinc metal undergoes oxidation. What is oxidation? Loss of electrons. By losing two electrons, zinc metal is oxidized to Zn plus 2 ions. Oxidation takes place at zinc rod, but generally oxidation takes place at anode. So which one acts as anode? Zinc electrode. Left hand side half cell acts as anode. Because generally oxidation takes place at anode. Oxidation takes place at anode. Okay, na? That's why zinc rod acts as anode. Left hand side half cell acts as anode. Automatically by induction, right hand side half cell acts as a cathode. Oxidation takes place at left hand side half cell. That's why it acts as anode. And reduction takes place at right hand side half cell. That's why it acts as a cathode. So due to oxidation, zinc metal converted into Zn plus 2 ions. Slowly these ions are dissolved in electrolyte solution and electrons released in oxidation process are accumulated on the surface of remaining zinc metal. So zinc ions are gradually dissolved in electrolyte solution. As a result, Zn plus 2 ion concentration in electrolyte solution increases. Weight of zinc rod gradually decreases. Zn plus 2 ions concentration increases. Weight of zinc rod decreases. Through the external circuit, these electrons reach cathode. Cathode దగ్గర ఏమున్నాయి? Copper metal placed in copper sulfate solution. Okay, na? సో ఇప్పుడు ఎలక్ట్రాన్స్ ఏది గెయిన్ చేస్తారు? కాపర్ మెటల్, కాపర్ అయాన్స్, సల్ఫేట్ అయాన్స్. న్యూట్రల్ కాబట్టి గెయిన్ చేయదు. పాజిటివ్లీ చార్జ్డ్ అయాన్ అట్రాక్ట్స్ negatively charged electrons. Therefore, at a cathode, zinc rod at a cathode or at copper rod, the electrons are released from zinc metal are gained by Cu plus 2 ions and reduced to C. Reduction takes place at the cathode. Therefore, copper rod acts as a cathode. Zinc rod acts as a anode. Copper rod acts as a cathode. Okay, so both oxidation and reduction takes place simultaneously. That's why this reaction is considered as a redox reaction. It is considered as a redox reaction. Due to redox reaction, electrons are transferred from anode to cathode. As electrons are transferred from anode to cathode, cell produces some electrical energy from cathode to anode. So, due to a redox reaction, electrons are transferred from anode to cathode. Flow of charges is called current. Kabatti cell generates some electrical energy from a redox reaction. The working of galvanic cell. Working of galvanic cell. So, మళ్ళీ జాగ్రత్తగా చూడండి. Due to oxidation and reduction. Due to oxidation and reduction. Electrons are transferred from anode to cathode. At a zinc rod, oxidation takes place. Due to oxidation, electrons are transferred from anode to cathode. So, what is the direction of electrons in electrochemical cell? Anode to cathode. And what is the direction of conventional current? Exactly opposite to direction of electrons. So, what is the direction of conventional current? Cathode to anode. So, due to accumulation of negative charges at a zinc electrode, it acquires negative charge. That's why anode is denoted by negative sign. Due to accumulation of electrons on the surface of this zinc rod, it acquires a negative charge. In generally electrolytic cell, anode is denoted by positive sign. But in electrochemical cell, it is denoted by negative sign. And by induction, copper rod acquires a positive sign. So in electrochemical cells, anode is denoted by negative sign, cathode is denoted by positive sign. Oxidation takes place at left hand side cell. Reduction takes place at the right hand side cell. Left hand side cell is considered as anode. Right hand side cell is considered as cathode. Generally, elements having high electropositive character acts as anode. Elements are having low electropositive character or elements are having high electronegativity acts as a cathode. So addition of two elements, which one acts as anode, which one acts as a cathode, and at identify as okay na? And next one. So elements are having low electropositive character. Elements are having high electropositive character. Suppose a galvanic cell is constructed by zinc and a hydrogen electrodes. Zinc and a hydrogen electrodes. So which one possesses a larger size? Zn possesses a larger size. So it has a high electropositive character. So it acts as the anode. Hydrogen acts as a cathode. Okay. So in this cell, which one acts as anode and which one acts as a cathode? Like a galvanic cell is constructed by magnesium and zinc electrodes. Magnesium and zinc electrodes. So which one acts as anode and which one acts as a cathode? So due to larger size, magnesium acts as an anode. High electropositive element is magnesium. That's why it acts as an anode. Automatically zinc acts as a cathode. Magnesium acts as an anode. Zinc acts as a cathode. Magnesium acts as an anode. And zinc acts as a cathode. Okay? So itla vadichinnappudu edi anode edi cathode ante large size or elements are having high electropositive character acts as anode. Okay, and elements are having small size or low electropositive character. Low electropositive character acts as a cathode. Okay, now ఇది anode and cathode identify చేయడం. And suppose a galvanic cell is constructed by hydrogen and oxygen electrodes. Which one acts as an anode and which one acts as a cathode? Which one acts as an anode and which one acts as a cathode? So hydrogen high electropositive element, oxygen high electronegative element. High electropositive element acts as anode. High electronegative element acts as a cathode. Okay, and a galvanic cell is constructed by hydrogen and chlorine electrodes. Hydrogen and chlorine electrodes. Then which one acts as anode? Electropositive element acts as anode. Electronegative element acts as cathode. Okay, now hydrogen acts as anode and chlorine acts as a cathode. Okay, and galvanic cells may be reversible or irreversible. Galvanic cells may be reversible or irreversible. A reversible galvanic cell must satisfy three conditions. So మళ్ళీ ఇంకోసారి జాగ్రత్తగా చూడండి. What is an electrochemical cell? A cell which produces chemical energy from A spontaneous redox reaction into electrical energy is called electrochemical cell. And generally electrochemical cells. Good morning, SAR. In electrochemical cells, element having low electropositive character acts as a cathode and a high electropositive character acts as for EAMCET Telugu classes 3. Already I told you SAR 20 to 50 per month. 20 to 50. SAR ఆల్రెడీ స్క్రీన్ మీద డిస్ప్లే అవుతుంది చూడు. ఆల్రెడీ స్క్రీన్ మీద డిస్ప్లే చేస్తున్నాను. ఓకేనా? ఎంసెట్ తెలుగు క్లాసెస్ కి 20 to 50. ఓకేనా? Or I will show a promotional slide. Promotional slide. See that promotional slide. You will get okay. You see this SAR for Telugu students. 1 month trial plan is 1 month trial plan is SAR. Last slide. Please watch last slide. In last slide for Telugu batches. For Telugu batches, Unacademy provides special batch. 1 month trial plan is 20 to 50. 20 to 50. By using my code, either KNR Live, okay, KNR Live, or by using KNR dash chemistry code, you will get 10% off. Okay, na? By using KNR Live or KNR dash chemistry, all are capital letters, then definitely you will get a 10% waive off. Okay, SAR. Okay. Okay. So which one acts as anode and cathode ఎట్లా recognize చేస్తామరా అంటే elements having high electropositive character anode, low electropositive character cathode. Okay, and next, a reversible galvanic cell. Must satisfy 3 conditions. First condition, if galvanic cell is connected to an external source of high EMF. So galvanic cell external source of high EMF connect cheste, then current flows from external cell to galvanic cell. Then normal reactions take place at respective electrodes. Normal reactions take place. Normal reactions means oxidation takes place at anode. Reduction takes place at cathode. Oxidation takes place at anode. Reduction takes place at cathode. In the first condition, to act as a reversible cell, galvanic cell must satisfy three conditions. First condition, if it is connected to an external source of a high EMF, then current flows from external cell to galvanic cell. Normal reactions take place at respective electrodes. Oxidation takes place at anode, reduction takes place at cathode. Okay. Second condition, if it is connected to, if a galvanic cell is connected to an external source of low EMF, external cell having low EMF, then current flows from cell to external cell, then reverse reactions take place. At a respective electrodes. The reverse reactions means oxidation takes place at the cathode and reduction takes place at the anode. If it is connected to an external source of low EMF, then current flows from cell to external cell. Then reverse reactions take place in galvanic cell. Oxidation takes place at the cathode, reduction takes place at the anode. And the third condition, if it is connected to an external source of same EMF, external source of same EMF, అంటే రెండింటికి సేమ్ ఈఎంఎఫ్ ఉన్నప్పుడు then no current flows in any direction. No reactions take place at the anode and cathode. Then it is called a reversible galvanic cell. So to act as a reversible cell, it must satisfy these three conditions. Okay. So time over. Thank you very much. Tomorrow I will explain problems based on Nernst equation and electrode potentials.